right, so we are back. Can you hear me? If you are here and you can hear me, please let me know in the comment section. Actually, if you can hear me, please let me know in the comment section. Um, so I'll continue. Let me see. All right. So okay, I can hear myself, so I guess you guys can hear me too. That's good. I was okay. First time my laptop crashed, my desktop crashed. So now I'm back. All right. So just a recap. So we imported everything and we instantiated the image data generator from Keras pre-processing image, and then we loaded the training data set. We loaded the training data set, and then we loaded the validation data set. And based on this, as you can see, the training data set has 37,000 images with 15 classes, and the validation data set has 8,000 images belonging to 15 different classes. So now let's import something else called OS. Import OS. So basically, this line of code will allow us to get a preview of the image names. So give me a second here to pull up what I'm looking for. Is see how much is in there. So one thing we can do is we could do something like we could tell it to give us the length of OS dot, and then in parentheses we can say train apple. We can repeat this process multiple times for each fruit, in each data set. So this is just for the training data set right here. And something else we can do is also get a preview of the images. So we could print out the images to kind of see what they look like. Yeah, we could print out the images to see what they look like. And quickly, I'm just going to test to make sure you guys can still hear me. All right, so you guys can still hear me, which is good. So to print out the images to see what they look like, we can do this. So we want to print an 8x8 image. Let's start with so this right here is just parameters for the graph. The images will be in a 4x4 configuration. and this is just the index for iterating over images. And here we just set up matplotlib figure. Okay, so we do figure is equal to plt.gcf, and then we set the figure that sets the size of the figure. So the inches is the number of columns times 4, and then the number of rows times 4. So this is kind of like creating a 4x4 image, a 4x4 graph. So we'll just print out images for, like, let's say apple and bananas, right? So we'll call this apple pick is equal to, this is kind of like a list comprehension, so there's that path dot join, and then we'll do the train apple directory, for f name and for f name and oh, so there's something else I need to create. So let me go ahead and add a distance. So we can create something that kind of lists the names of the different fruits. So before I do that, let me define, let me see. This is the apple directory, and then this is printing the number of apples in train data set, and let's call this train banana directory, and this is the banana directory, and this is printing the number of bananas in train data set. All right, so let's call this number banana, and I believe it's just called banana. Okay, so let's change this to banana. Okay, it's equal to train banana number of banana. All right, so this looks right now. So we have 4,000 apples in the training data set, and then we have 2,000 bananas in the training data set. So this is kind of how you could list the different. So this is how you can find out how much of each fruit type is in each data set. Now, now we are going to list the names of these images. Okay. So for us to list the names of the images, we'll do something like, let's say, apple names. is equal to os dot list dir, and then in this case we'll do give me a second here. We'll just do train apple dir. All right, and let's say and let's do apple names, and let's kind of just do the first 10. So why is IPython checkpoint part of the name? Okay, that's crazy. So we have, like apple. So these are the names of the files in this apple directory, and IPython checkpoint shouldn't be there. So let me see. Let me go ahead and move this. There shouldn't be an IPython checkpoint right there. So if we go to banana, did the same thing happen now? Okay. Everything else is good. Okay, for some reason IPython checkpoint got saved inside apple. That's not right. So let's run this again. As you can see, that IPython checkpoint is gone. Let's see. So that shouldn't. So this looks like a duplicate of this. Let's go ahead and get rid of that. I think it should be easy to spot. Right there. This shouldn't be there. Let's go ahead and delete that. Go back here. And then let's run this again. Alright, so that one is gone. So we can repeat this process for banana names, and we are going to be using these variables very soon, which is why I'm kind of doing this. So let's call this banana. What am I doing? Train banana directory, and let's call this banana names. So these are like these are the names of the bananas. These are the name of the images inside the banana folder for the training data set. So now we are going to use this to kind of print the images. So what we are trying to do here is print the images that we are going to be classifying, just to get a preview of what they look like. So objective is to print images to get a preview. We are not going to print all the images for all the different types of fruit, categories of fruit. We are just going to print the images for bananas and apples, just to get a preview of it. So we are saying join the name and the directly for, and let's see, and apple names. Apple names this, and then pick index that we defined earlier here from -8 to and we are going to repeat this process for, let's say, bananas also. And let's call this banana names. Alright, let's go ahead and run this cell. Before we run that, let's go ahead and run this first. Okay, let's see. Name n rows is not defined. I keep doing this every time. N rows n rows right there. Alright, so let's go ahead and actually plot this. Image, and let's say enumerate. So we want apple pick. We want it to enumerate to apple pick, banana pick. All right, and then this is just us setting up and which starts, let's see, subplots start at index 1. So number of rows, number of columns, I plus 1, and then we'll do sub.axis, and we'll turn, this is basically turning off the axis, so this is turning off axis. Don't show axis. So image is equal to, so this mpings we like earlier, this mping is coming from right here, from matplotlib image function, and then we want to read the image path. Okay, and then we want to plot, we want to show the image. And now let's show everything. Let me see what the problem is. Okay, so for list object cannot be interpreted as an integer. Oh, this is supposed to be a plus. Yeah, that's supposed to be a plus right there. All right, so everything works now. So we have here, we have a preview of apple images, and we have a preview of banana images, and of course you can repeat this process for like all the other images, but I just wanted to show you that you can get a quick preview of the images in your data set. So let me see if you guys have any question. No? Alright, so basically, so what we've done so far is we imported different libraries and we loaded the data using the image data generator, and then we flowed from directory, like we use flow from directory to load the images. So this is basically instantiating the image data generator, and then we use the train directory to load the images. We use the .flow from directory to load the images, and this is the training directory that contains the images for Apple. This is the validation directory that contains the images for also Apple and the other 15 different categories, and it tells you the training directory has 30 this much images and it has 15 different classes, and the validation directory has 8,000 images in 15 different classes. And basically this line of code is just for us to see, okay, so we have 4,000 images of Apple in the training directory, and then we have 2,000 images of banana in the training directory. And then here is basically just listing the names of the different fruits inside the training directory, inside the Apple and banana folders. And basically this is us printing out the images just to get a preview of what they look like. So that's what we've done so far. There's no questions here, so I'm going to keep going. And so I'm trying to find a good stopping point for today. So the next objective is kind of to build the model that we're going to be using to train this data set. So we are going to have multiple multiple neural networks inside this. So I actually don't know how much, I don't know like how many neurons I'm going to need. So I'm just going to start building a model for this, and then based on the results of the model, I'm going to have to tweak it a little bit. So the model is equal to, let's say, TensorFlow.Keras.models.sequential. And this is how you build a model. So I'm going to start by using a convolutional layer, and this convolutional layer is going to have a 3x3 filter. And let me just start building and I'll explain as I go. TensorFlow.Keras.layers.con. Alright, so basically I'm going to start off with 64 3x3 filters for this, and then based on the results of this model, then I'm going to decide, oh, do I want to like change the type of filter I'm using. So basically this the convolutional layer is like a filter. Just think of it as a filter for an image. Okay, and then this network layer needs to be activated, and there are different activation that you could use, but basically this ReLU right here, what it does is it actually, let me find out like the word for word definition of this real quick. I wrote it down somewhere and I just can't remember. All right. So ReLU. Let me see. Give me a second to find the definition for ReLU. So give me a second here, and now we're also going to look at the documentation. Okay, so let me add this here. How do I add? And this is going to be a markdown. Let's just make it a code. All right, so basically ReLU means if x is greater than 0, return x, else return 0. So this is kind of what the ReLU activation is doing. So basically it is saying, so it passes only values that are 0 or greater to the next layer in the network. So this right here is the first layer in the network, and with this and without an activation, this layer will not be activated. So this activation is telling this ReLU activation is telling us that only pass numbers that are 0 or greater to the next layer in the network. I'm just going to begin with like 3 layers, or I don't know how many layers will be necessary to train this data set. So I'm just going to start with 3 layers. And with this, then we have to do input shape. Input shape is basically saying this is the shape you want the data to be in. Okay, and these images are in colored images, so they're going to be 3 bytes. So if this was grayscale, if grayscale images, if this was black and white images, then we'll have 1 byte right here. And then we'll just have 1. But since these are colored images, we'll have 3. And basically this 3 is like 1 for red, 1 for each of the primary colors. Okay, so that's basically that layer. And now after we add a layer that filters the image, like how this layer actually filters the image is a whole different conversation. Like we can talk about that later in a different video. We can discuss how image filtering, how convolutions work. But this video is mostly focused on just building the project. After we filter it, then we have to pull the image, and we use a max pooling in TensorFlow to do this. So then we do TensorFlow.Keras.layers.max pooling 2D. Okay, and in this case we use a 2x2 to pull it. Again, like I know how convolution to how max pooling works and how image filtering works, but this is really not like the video to explain that. So this here is the first two layers, and then we are going to create a second convolution. So this is first convolution. I think I'm just going to create 3 convolutions just to start out, and then after training the model, we will kind of like decide if we want to add more convolutions or take some off, if we want to like use other people's models to do transfer learning, so this is just kind of like minimum viable product, just creating like the initial first thing. And let me see if you guys don't have any questions, which is fine. So this is the first convolution, and then the second convolution is similar to the first one, and in this case we just still use 64 filters and a 3x3, a 64 3x3 filter, and then we also use activation ReLU. And right now for this one we do not put an input shape because the input of this layer is the output of this layer. Okay, so this doesn't need a specific input shape. Then we'll do the same thing that we did here. Use a 2x2 max pooling. So now let's create the third layer. Well, this does need a comma. Third convolution layer. And then something's not right. There we go. And the third convolution layer is just going to be similar to this. And basically the input of this layer, it will be the output of this layer. All right. And then we can add like one more convolution layer. Why not? So we can actually, let's say let's use different filter sizes for the third and fourth ones. And now after we have done everything, we need to like, after adding our convolution layers, we need to flatten it before feeding it into the deep neural network. So basically all of this right here, all of this is basically like, in this case we are like putting a filter over the images and then doing max pooling, and then take the output of this layer and do the exact same thing in this layer. Take the output of this layer and do the same thing. Take the output of this layer and do the same thing here. And now after we have done multiple convolutions and max pooling, it should reduce the size of our image. And now we are going to take the output of our last convolution layer and feed it into our deep neural network. But first we have to flatten the images. And then if we didn't do this process right here, if we didn't have all these convolution layers, we would have done like input shape equal to 150 by 3 right here, as opposed to up here. But we have all these convolution layers, and this is the first layer that receives the images, so you need to have the input shape defined. So we'll begin by this is like the dense layer. So after you flatten the image, then you add this into your dense layer. And let's just start with 512 neurons. So basically this right here is means 512 hidden 512 neurons in the hidden layer. Okay, so basically in this case we are taking the flattened images and we are feeding it into our dense layer with 512 neurons. Like, this may not work, we may have to come back and tweak this a little bit and maybe change it to 1024 neurons, but let's just start with 512 neurons and kind of see the result and see what's going on first, and then we'll move on from there. And in this case, we'll do activation equal to ReLU. All right. And then the last thing that we do is the last layer in this is basically telling us how many categories we have. So 15 equal to 15 different categories. All right, so we'll put 15 right here, and then we'll do activation equal to softmax. If this was let's say, for example, if this was 2 categories, right here we'll do sigmoid as the activation, but because this is like more than 2, would this is 15 different categories, we'll use softmax as the activation for this particular neuron. And let me define softmax for you so you know what it means. So softmax takes a set of values and effectively picks the biggest one. For example, if the output layer has, let's say, I don't know, 0.1, 0.1, 0.5, 0.2, 0.1, it will take it and turn it into 0, 0, 1, 0, 0. So that's basically what softmax does. It takes a set of values and effectively picks the biggest one. So basically, from the fundamentals level, the model is done and the model is kind of built right here. And I'm just looking up something real quick. Okay. So basically, this is our model right here. And of course, like I said before, we'll come back and modify this model as necessary. Huh. Mm, what did I miss? Oh, there. Okay, just some warnings. Let me see. If I do this, is it going to? Yeah. So the warnings goes away. Now we can get a summary of our models. So let's do model dot summary. So basically, right here, this is the model that we just built. Okay, if we input a 150 by 150 images and pass in a 3 by 3 filter, what comes out is 148 by 148 images. And then if we do a max pooling, a 2 by 2 max pooling, the output is a 74 by 74. And then this 74 by 74 goes into the next layer, and which we pass a 3 by 3 filter through it. And then what the output is a 72 by 72 image, and then 2 by 2 max pooling layer, which produces a 36 by 36 images. So as you can see, this is kind of like the process that we are going through until we come down to a 7 by 7 image. And this 7 by 7 image is what goes into the flattened layer, and then we pass in the 512. Then we use the 512 neurons in the dense layer, and then this is 15 different categories. So of course we'll come back and tweak this model as time goes by. But I just want to finish like one thing before we call it a day and then continue tomorrow. So now we are compiling. So right now what I'm going to do is compile the model. Okay, so model.compile. And here I want to give it a loss function. So in this case I'm going to use categorical cross entropy. So if you go to Jupyter Lab, or not this, if you go to TensorFlow documentation and let me see, loss. Loss function. I don't know if this is what I'm looking for, but we'll see. Okay, yeah, so yeah, these are the loss function. So there's different categories of loss function. And this right here, I'm using categorical cross entropy. And then binary, you can use binary cross entropy if if you had like two categories, but in this case I have multiple categories, so I'm using the categorical cross entropy. And then you have to pass in the optimizer when you compile stuff, and in this case I'm going to use the RMS prop that I imported earlier. And then the metrics we are going to be using is accuracy. All right, so that's model.compile. So basically now it's time to fit the data set. Now with model.fit, we are going to be fitting this data set through this model right here. So because this is a large data set, we have about 37,000, you know, training images and then validation images is a lot. So I think this is going to take some time, which is why I wanted to get to this point. And I think this will probably be the last thing we do today for this live stream. Yeah, this will probably be the last thing we do today for this live stream. And then tomorrow we'll focus on kind of analyzing the results of our live stream and maybe optimizing some things. So yeah, so let's run this data set through our model and see what happens. So you can just do model.fit generator. All right, and we want to fit out. So the first thing is you define your training data set. So if we go back up here, the train gen is our training data set and val gen is our validation data set. Okay, so we'll do train gen and then we'll do epochs. So in this case I'm probably going to run it for 100 epochs. My computer is probably going to crash again, which is not good. So validation data, I will do the val gen. I think that's what we name it. So so yeah, this is the validation data set. And then we just do verbose equal to 1. Basically we just wanted to, verbose is telling us how much of the process it should print. So I'm going to save this, but I'm not going to run it. I'll go ahead and upload this to GitHub just in case my computer crash. Like, I'm not even kidding. So I'm actually going to save this in a variable and be like let's call this something. Let's call this fruit model. The reason why I'm saving it in this this is so that later we could call the history parameters from it. And then yeah, anyways, so I'll go ahead and save this on GitHub just in case my computer crash while I'm trying to run it. So let's call this upload files. Model built and about to run. So this is the lazy way to put your files on GitHub, but my philosophy is as long as it works, there's no point in like, you know. So this is going to take a long time because of those images, but Let's see. Hold on. Why? Um, do we need to put this here individually? Huh. Usually this works, so I don't know why this is not working right now. Oh, so it needs to be fewer than 100 files. That's what so the data set itself cannot go on GitHub, but everything else can go on GitHub. That makes a lot of sense. So the data set cannot go on GitHub well, as it is right now. We need to create a compressed file for it. So let's put this into a compressed file. Wow. So anyway, I'll deal with this later. And let's just comment this for now. And then later I'll put the data set in a compressed folder. Once it's in a compressed folder, it will make it easier to upload to GitHub, because I want the data set on GitHub. All right. So let's go ahead and run this and let's see what happens. So it's running the first epoch. Like I said 200 epochs. So this is going to take time to run. Like seriously. So that's basically it for today's live stream or today's one. This is how I'm going to go, because I know this is like building the model is going to take a long time, and right now it's like 9:20 p.m. my time. So I'm going to end the live stream, but when we come back next time, we will look at the results of our model.fit generator, kind of see the results, and then see it's printing out the accuracy right here, and then the loss function. So we'll basically look at that, and then we can graph the loss function versus the accuracy to kind of see how our model performed. And based on our model performance, we can go back and tweak our model again to kind of see how to improve the model. But this is going to take time to run. Yeah. And also next time we'll after doing the graph, we'll also upload some images to kind of see. We'll like maybe grab images from the internet, and let's say upload an image of an apple to kind of see if our model can categorize the apple. So yeah. And eventually I want to get to a point where we could like upload this online, and so other people can play with it. Other people can upload images of, let's say, different fruits, and then get the result for it. But anyway, yeah, this is going to take a long time. I'll just let it run overnight. Thank you for watching, and I'll see you on the next video. The next video is just gonna be titled the exact same thing, but it will be called part 3. So yeah.